yesterday about molecular orbital theory, and based on molecular orbital theory, energy level diagram for molecule or the species up to 14 electron species and above 14 electron species explained. Then here one important point about bond order. Bond order BO is equals to 1 by 2 into NB minus NA. Here NB indicates number of electrons, total number of electrons present in bonding molecular orbitals, and total number of electrons present in anti-bonding molecular orbitals. So on the basis of this, here any species or molecule based on bond order, regularly they'll ask stability of the molecule. For example, if NB is greater than NA, number of electrons present in bonding molecular orbitals, then such molecule is a highly stable molecule. Stable molecule or the stable ion it is. If NB is less than NA or NB is equals to NA, generally such molecules or the species are unstable. Those who are having NB equal to NA molecule generally cannot exist. Even it is exists, that is unstable. In such cases, NB is equals to NA, bond order both are equal, bond order is equals to 0. If bond order 0 indicates in such a molecular species between atom and atom or molecule there is no bond, just only weak van der Waals forces exist. On the basis, here number of electrons present in bonding molecular orbitals are greater than anti-bonding molecular orbital, the species is more stable, and if it is more stable, molecule exists and its strength also increases. Here next important point is number of bonds increases. Number of bonds increases. Here bond order also increases. So the number of bonds increase between two atom of elements, bond order also increases. Here bond strength also increases, and bond energy also increases. This is. So here based on this bond order, we can find out bond length, bond energies, and the stability of the molecule. Yeah, for object there is a small important shortcut to find out the bond order. Here number of total number of electrons in a species and its bond order BO. Direct a shortcut by seeing the species any molecule, easy to identify its bond order. Now here maximum on the basis of this table, they'll create some important questions. Here total number of electrons in a given species take 14 electrons, then its bond order is equals to 3. Here number of electrons increases, bond order 0.5 decreases. Here 16 electrons are, its bond order is 2.0. 17 electrons, here it is 1.5. 18 electrons, its bond order is 1.0. 19 electrons, its bond order is 0.5. 20 electrons, its bond order is 0.00. Means there is no bond. Now this is the standard value, that is total number of electrons in that species 14 electrons are present. Its bond order is 3. 3 means between a species there exists a triple bond. Like it is a 2.5 is not an accurate whole number. It is a fractional value. That's why bond order may be a positive or a fractional value. Some cases negative value also exists. So total number of electrons increases from 14 to 20. Its bond order is decreased by 0.5. Then its number of electrons decrease 14 to 13 electrons. Bond order again here the 2.5. 12 electrons here 2.0. 11 electrons here the 1.5. 10 electrons, its bond order is 1.01. So the bond order is 1 is there is a single bond. Between A and A, single bond is exists. If bond order is 2, between A and A, there exists a double bond. Number of bonds increases, bond length decreases. So the bond order is directly proportional to number of bonds. So the number of bonds increases, your bond length decreases, inversely proportional to bond length, and directly proportional to the bond energies. Very, very important this is. So by using this table, I'll create some important examples, simple examples. Then after this shortcut, I'll introduce how to fill the electrons at their respective energy levels. Okay. So here, I'll take one simple example, O2 molecule it is. So its oxygen atomic number is 8. Oxygen molecule is 2 oxygen atom contain 16 electrons are there. This molecule is formed by the combination of oxygen plus oxygen. It gives O2 molecule. Yeah, total number of electrons are 8. Here also 8. Total here molecule 16 electrons are there. No doubts. By using this table shortcut for objective, in O2 molecule, molecular species based on MOT, its bond order is 16 are there. 16 means bond order is 2. That's why yeah, the O2 molecule, its bond order is 2. Between oxygen and oxygen, there exists a double bond. Without any energy level diagram, easy to identify by using this table shortcut. Then here N2 molecule is there, nitrogen molecule. Also it is formed by N plus N against N2 molecule. Atomic number of nitrogen is 7. Here are 7. Neutral atom, 7 electrons and 7 protons are there. That's why, yeah, total number of electrons are 14. 14 electrons means according to this, your bond order is 3. So here between nitrogen nitrogen there exists a triple bond. Number of bonds increases, bond length decreases, bond energy also increases. Okay. So here helium molecule is there, Ha2 is there, like neon molecule like Ne2, like argon molecule like krypton molecule. These molecules do not exist. Noble gases do not exist according to MOT. Yeah, bond order for all these molecules 0, 0, 0, 0 means in this case the number of electrons present in bonding molecular orbital must be equal to number of electrons present in anti-bonding molecular orbitals. So its bond order is equals to 0. There is no bond between helium or neon or krypton or any noble gases. Just there exists a van der Waals forces, so weak van der Waals forces. Here, I'll take a neon simple example. Here the neon plus neon, it gives neon molecule, Ne2 molecule, 10 atomic number, here also 10, total 20 electrons are there. If it is 20, its bond order is equals to 0. So here bond order BO for this neon molecule is equals to 0. So here there is no bond between neon and neon. Just weak van der Waals forces exist. Sure? Sure. So here oxygen, nitrogen, helium, these are the molecular species. In this molecular species, just these are the neutral molecule, oxygen, nitrogen, helium or neon, argon or krypton, whatever it is. If they'll ask based on this MOT, some ions, positive and negative ions, how to calculate its bond order. Now here, I'll take one simple example based on this oxygen O2. Here O2 minus 1 I'll take. This O2 minus 1 is called a superoxide ion. Very, very important this is. Because in examination, instead of giving O2 minus 1, they'll give what is the bond order of oxygen in a superoxide ion. For superoxide ion, compulsory we want its molecular formula or the species. For this superoxide ion, here O2 and there is a minus 1, that minus 1 indicates to the total molecule 1 electron is added. That's why oxygen plus oxygen minus 1, here 7. Here 7 plus 1 electron is added. That's why 8 total number of electrons in superoxide ion are 17 electrons. Sorry. Here 8 and here 8, 16 plus 1, 17 electrons are present in its molecular species. Now, according to this shortcut, bond order of oxygen molecule, if it contains 16 electrons, bond order is 2, but here 1 electron is added in one oxygen atom. Originally, it contains 8 electrons and here 8, 1 electron added, total 9 plus 8, 17 electrons. If it contains 17 electrons, its bond order is this 1.5. So for superoxide ion, bond order is 1.5. It is a fractional order. It is not a direct whole number, fractional number. Maybe bond order may be a whole number, or the fractional order, maybe positive or negative values takes place. Its bond order is 1.5 for a superoxide ion. If it is peroxide, that is O2 minus 2, 2 electrons are added. This is called a peroxide ion. Peroxide ion. Here 2 electrons are added to the oxygen molecule like minus 1, O minus 1. Here 7 plus 1, 7 plus 1. 8 electrons and here 8 plus 1 and here 8 plus 1. Total 9 electrons and here 9 electrons. Here total O2 minus 2 contain total 18 electrons. So the species contain 18 electrons according to the shortcut. Here bond order is equals to 1. For this, BO is equals to bond order is equals to 1. There exists even a sigma covalent bond between oxygen and oxygen in a peroxide ion. Like, based on the simple shortcut table, we can create for any molecular species its bond order. All these are the homodiatomic molecular species. Neutral, here neutral, neutral. These are the molecular species of homodiatomic molecule. On the basis of this, if they'll ask in examination heterodiatomic molecules, regularly they'll ask based on this. Which of the following species bond order is similar with the following? Like questions, I'll create very simple questions. Here for heterodiatomic molecule, here heterodiatomic molecule best example is carbon monoxide, CO. So it is formed by the combination of carbon plus oxygen. Now the carbon atomic number is 6, oxygen is 8. Total number of electrons present in carbon monoxide are 14 electrons. These 14 electrons indicates its bond order is 3. Now, in this oxygen and carbon between there exists even triple bond because bond order is 3. This is similar to the nitrogen molecule. So, based on this, one more example is Cn minus. Now, here the carbon plus N minus, carbon 6, nitrogen atomic number is 7 and 1 electron is added plus 1, here 8 electrons plus 6 electrons. Totally are 14 electrons are present. Now it is the Cn minus. See here, its bond order is 3. Now this is also equal to similar to the nitrogen molecule bond order. So for bond order, if they'll ask any diatomic homo or heterodiatomic molecular species, better you remember this a simple table shortcut, easy to find out its bond order. If you know the bond order, then bond length, bond strength, number of bonding and anti-bonding electrons are easy to find out. Based on this table, they'll create like N2 plus 1, N2 plus 2, N2 minus 1, N2 minus 2, like they'll create some 4 to 5 important molecular species. Then based on this, increasing and decreasing order of their bond order is, we know the increasing, decreasing order of bond orders, then is to find out its bond length and the stability of the molecules. We know already one basic simple shortcut, and if we can identify the number of electrons present in this species, by using this table, easy to identify its correct bond order. See here, for nitrogen molecule, total number of electrons are 14 electrons. From nitrogen molecule, plus 1 means 1 electron is removed. That's why your 14 minus 1, 13 electrons. Your 2 electrons are removed, minus 2, that is 12 electrons. Your minus 1 means 1 electron is added. That's why 14 plus 1, 15 electrons. Your 14 plus 2, that is 16 electrons. Here it is a neutral molecule, nitrogen molecule. On the basis of total number of electrons present in that molecular species, by using the table, if the molecule or the species contain 14 electrons, its bond order is 3. Your bond order is 3. 13 electrons are there, its bond order is 2.5. Now its bond order is means number of electrons are 12, its bond order is 2.0, and 15 electrons are there, the 2.5. 16 electrons are there, bond order is 2.0. So by using this table, increasing and decreasing order of their bond length or bond order or the bond energies, they'll ask. Based on this, for nitrogen molecule, bond order is 3. So increasing order of these. First place, 2.5 and 2.5 both are having the same bond orders. 2.0 and 2.0 both are having the same bond orders. In such cases, we can easily decide which one has a higher stable in nature or bond energies. Means on the basis of energy level diagram, we can find out those molecules having more number of bonding electrons than compared to the anti-bonding electrons. That is more stable and its strength is more. Best example, best important point is here. Species having the same number of electrons or the different electrons, in such cases, both are having the same bond order. By using a number of bonding and anti-bonding electrons, we can identify easily its stability or the bond energies and bond orders. Better remember this simple shortcut. By using this simple shortcut, easy to manage its bond order. So on the basis of all these important points, just I'll give the energy level diagram. That energy level diagram, shortcut energy level diagram, is required to find out the number of bonding and anti-bonding electrons in any molecular species. To find out the magnetic behavior also compulsory, simple shortcut energy level diagram required. Yesterday, For explained about MO theory based on MO theory energy level diagram, below 14 electrons and above 14 electrons energy level diagram. First, I'll take a simple rough diagram. Then I'll take a nitrogen molecule. That nitrogen molecule contains 14 electrons. How the electrons takes place, filling of electrons takes place from lower energy level to the higher energy level. Just I'll explain, listen here. Your nitrogen combines with another nitrogen atom. It gives a nitrogen molecule. Atomic number of nitrogen 7 and it contains 7 electrons. Now molecule contains total 14 electrons. So total number of electrons present in nitrogen molecule are 14. Based on this, your electronic configuration of nitrogen 1s2, 2s2, 2p3, it also 1s2, 2s2, 2p3 like this. We know already below 7 are electrons, 14, below 14 electrons molecular species. Electronic configuration is kk, sigma 1s, sigma 2s, sigma star 2s, pi 2px equal to pi 2py, sigma 2pz, pi star 2px equal to pi star 2py, then sigma star 2pz. This is the energy level diagram. Electronic configuration for nitrogen molecule. So on the basis of this electronic configuration for this kk, we can write sigma 1s and sigma 1s, sigma star 1s. Now here in two atoms, nitrogen atoms, so 1s and 1s linearly combines. And here the 2s orbital and 2s orbitals linearly combines, forms molecular orbitals. Then again here 2p3 and 2p3 of two nitrogen atoms are linearly combined, so it gives corresponding molecular orbitals. Here I'll take increasing order of their energy level is this. It's the increasing order of their energy level, two atomic orbitals. First one is 1s. Now in one nitrogen atom atomic orbital, nitrogen atomic orbital 1s2 and here also 1s2. Your electrons are 2 are present here. These two atomic orbitals linearly combine. Yesterday explained about linear combination of atomic orbitals. Then it forms two molecular orbitals. One is bonding, another one is anti-bonding molecular orbitals. According to the above principle, while filling the electrons into respective atomic orbital, lower energy atomic orbitals are first filled, then electrons, excess electrons are present, they are paired up and entered into the higher energy level. Same similarly, your 1s of nitrogen atom donate one electron to another nitrogen atom. It is also donate one electron and forms an electron pair. That electron pair first entered into the lower energy, that is a bonding molecular orbital 1s, that is 2 electrons are present, that is 1s2 electronic configuration. Next, one more electron is present in nitrogen atom in 1s. Again here 1s, it donate one electron pair that is entered into the next higher energy level, that is sigma star 1s2. So after filling in this nitrogen atom, electrons are again present in a 2s, that's why entered into the second main energy level of S subshell. Now again it forms here two molecular orbital. One is bonding molecular orbital, another one is anti-bonding, as like 1s2, here also 2s2 and here 2s2. Here 2 electrons and here 2 electrons are there. Now each one donate one electron and entered into the lower energy, that is sigma 2s2. Then again 2 electrons are present, they are entered into the next higher energy level, that is sigma star 2s2. Then after completion of this 1s and 2s, then again one more energy level is there, that is subshell p subshell, that is 2p. 3 electrons are there. Now these 3 electrons are present in 3p p orbitals px, py, pz. Pz is considered as an internuclear axis. Already yesterday explained electronic configuration. Reason explained last class why this electronic arrangement takes place to avoid the intermixing of sigma star 2s and sigma star sigma 2pz, to avoid the intermixing of these two atomic orbitals. Just rearrange their electronic configuration. That's why atomic number 7 are the total number of electrons 14 containing molecular species. Energy level diagram, sigma pi 2p x and pi 2p y has lower energy than compared to the sigma 2p z. Now here 1, 3 electrons are present in 2p subshell, and here also 3 electrons are present. It is px, py and pz. Here also px, py and pz. Now px of one nitrogen atom donate 1 electron to this another nitrogen atom px. It forms one electron pair. That electron pair cannot enter into the at a time in 2px, because here two energy levels both are having same energy. According to Hansen rule, these two electrons are cannot enter into the any one energy level equally share. That's why here 1 electron and here 1 electron is present. That is according to Hansen rule. Now here the py and py equally contributes and it forms an electron pair, that is again equally shares, and it gives one more electron pair here and here. That's why its electronic configuration is pi 2p x2 to pi 2p y2. This is then sigma bond, that is pz and pz linearly combines. It forms one sigma covalent bond. They are entered into the here higher energy, that is sigma 2pz2. Electrons are completed, but here higher level anti-bonding molecular orbital, as usual vacant orbitals are present. These are pi star 2px and pi star 2py. Now this is the sigma star 2pz. This is the filling of electrons in molecular species, that is the molecular species containing total number of electrons 14 or below 14, same energy level diagram. If it is only hydrogen molecule, use up to here. If it is lithium, this and this. If it is beryllium, this and this. If it is boron, use this, this and this. Based on this, we can easily fill the electrons into a respective energy level. So here, based on this, bond order is easy to find out by using this shortcut, no doubts. But the electron filling must, because to find out the magnetic behavior and magnetic moment, and to find out the number of electrons present in bonding molecular orbitals and number of electrons present in anti-bonding molecular orbital. So here, in that nitrogen molecule, once we can observe all the atomic orbitals either side, 1s is completely filled and 1s is completely filled, and 2s also completely filled. Atomic orbital, I am saying about atomic orbitals, not about molecular orbitals. Now in this atomic orbital, you have 3 unpaired and 3 unpaired. Don't observe these 3 unpaired and 3 unpaired. By using the unpaired electrons, don't estimate its magnetic behavior is paramagnetic in nature. After completion of this filling of electrons into a respective energy level, just observe the molecular orbitals. Don't observe the atomic orbitals. These are the molecular orbitals. These are the center orbitals or the molecular orbitals. In this, it is completely paired. It is also 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 paired. There is no unpaired electrons in nitrogen molecule. Not only nitrogen, any molecular species in molecular orbital which contain a completely paired molecular orbital or vacant orbital. In such cases, magnetic behavior, in such cases, there is no unpaired electrons. There is no unpaired electrons means n is equals to 0 electrons. Such molecular species are diamagnetic in nature. There is no strong attractive in nature. Means here there is no such a attractive or the repulsive natures because all are paired. That's what is a diamagnetic in nature, and its magnetic moment also equal to 0. That is mu is equals to square root of n into n plus 2 bm. Its magnetic behavior also equal to 0. Clear? By using this, if they'll ask n2 plus 1, what is the meaning of n2 plus 1? One electron is removed from nitrogen molecule. That electron is removed always from higher energy level. It is the higher energy level. One electron is removed from here. That's why here the sigma 2p z1 it is. Electronic configuration also changed. Now here the nitrogen molecule N2 is a diamagnetic in nature, whereas here the N2 plus 1 is a paramagnetic in nature, because here n is equals to 1 unpaired electron, here n is equals to 0 unpaired electrons are present in it. So to estimate the number of bonding and anti-bonding electrons, and also to find out the magnetic behavior and magnetic moment, compulsory we want a rough diagram, at least this energy level diagram. If it is N2 plus 2 is there, for example, 2 electrons are removed. That's why from here electron is removed. Now it is also completely paired. The number of electrons decrease, but it is also completely paired. Now here N2 plus 2 is, again it is a diamagnetic in nature. Number of unpaired electrons are 0. In this manner, any molecular species, by using the total number of electrons, then easy to find out its magnetic behavior. Is it diamagnetic or paramagnetic? By using that, easy to identify its magnetic moment. Similarly, for O2 molecule, oxygen molecule, already according to the VBT or Lewis dot structure, your O2 molecule is a diamagnetic in nature. Starting itself explained to you. But according to this theory, your O2 molecule is a paramagnetic in nature. This is according to MOT, molecular orbital theory. So I'll show this energy level diagram for oxygen molecule. There's slight variation for both the nitrogen and oxygen. Same energy level diagram. Just here oxygen and oxygen combined gives O2 molecule. 8 plus 8, 16 electrons. Above 14 energy level diagram. Slight variation. That is at this 2pz energy level only differs. Everything is same. Now here in this case, your 2pz energy level is lower energy. This is the lower energy. And here the pi 2px and pi 2py are the higher energy. That is the difference. Remaining everything is same. Now this is sigma 2pz. Yesterday explained why this is arranged above 14 electrons. Here the sigma star 2s and sigma 2pz cannot intermix with each other after the atomic number 8 or 7, or number of electrons present in species more than 14 electrons are present. They cannot intermix. That's why just arrange like this. Yeah, 16 electrons are there. Now here 2pz is there. First the sigma bond is formed according to this. And here oxygen electronic configuration 1s2, 2s2, 2p4. This 1s2 clear, 2s2 clear, 2p4 only. Here already 3 electrons are there. Here already 3 electrons are there. One more electron. That one electron is compulsory. Better you write in X only. Don't write in Z atomic orbital, because yeah, the px and the px first cannot overlap. First pz and pz overlap because it is a lower energy. Electrons are entered here because 2pz and 2pz linearly combines, it forms like. Then here the py and py linearly combines, equally shares here 1 and here 1. Then again px and px again linearly combines, it forms one electron pair here. Then again if you can write pz in pz, this pz and pz combines linearly, they are entered into the sigma star 2pz without filling this lower energy level. According to the above principle, electrons cannot enter into the higher energy level. That's why don't fill the electron in pz, the fourth electron, better you take in px. Now z is the internuclear axis. Now here the px and the px again combine. That one extra electron is present here pi 2px and pi 2py. That's why here one electron and here one electron entered here. See here, these are the Centronista molecular orbitals. Some are bonding molecular orbitals, some are anti-bonding molecular orbitals are there. In this, in anti-bonding molecular orbital, that is pi star 2px, one electron. Here pi star 2py, one electron is there. Two are the unpaired electrons. That's why here in oxygen molecule, according to the VBT, all are the paired. There is no unpaired electrons. That's why it is a diamagnetic in nature. This is disproved by MOT, molecular orbital theory. According to this molecular orbital theory, according to the Hansrud and R.S. Millikan, oxygen molecule is a paramagnetic, and experimentally proved it is attracted slightly towards the magnetic field. That is due to the presence of two unpaired electrons. That's why according to this it is proved it is a paramagnetic, not diamagnetic, because it contains two unpaired electrons. Its magnetic moment of mu is equals to square root of n into n plus 2 bm. Now it is square root of 2 into 2 plus 2. That is root 8. Root 8 means 9 is nothing but here the 3. Root 8 means 2.89 bm Bohr magnetron. Similarly, if they'll ask, just like n2 plus 1, n2 plus 2. If they'll ask here O2 minus 1, O2 minus 2, O2 plus 1, O2 plus 2, like if they ask any molecular species, by using this easy to fill is to find out number of bonding and anti-bonding molecular orbitals. See here, in oxygen molecule, total number of, in this case, in oxygen molecule, total number of electrons present in a bonding molecular orbitals are how many? Easy to find out. Your bonding means lower energy level. In 1s, here 2 electrons are there. In 2s, here 2 electrons are there. And here in 2p, total 6 are there. See here the round of 6. Here the 2, here the 2. Total how many? 10 electrons are there. A number of electrons present in anti-bonding molecular orbitals are Na. See here, star mark, higher energy level anti-bonding. Here 2 electrons, here 2 electrons, here 2 electrons. Total how many are there? 6 electrons are there. Now here the NB is greater than Na. Number of bonding electrons are more than compared to anti-bonding electrons. That's what is a stable molecule. Now its bond order is calculated by using this 1 by 2 into NB minus Na. Now it is 10 minus 6, that is 4 by 2, that is 2. So bond order 2 is nothing but between oxygen and oxygen there exists a double bond. One is sigma, another one is pi covalent bonds. Sigma covalent and pi covalent bonds are present. But some are generally considered, instead of taking 10 electrons to find out the bond order, your number of electrons present in 1s, sigma 1s and sigma star 1s, both are the same, get cancelled. Our number of electrons present in sigma star 2s and sigma 2s and sigma star 2s cancel. Finally, difference is in p orbitals only. That's why instead of this, here we can take like this also. NB are the 6 electrons only in p, and NA are only 2 electrons are there. Then finally, by applying same answer, we'll get it. There is no change in that bond order. That's why to get the number of electrons present in bonding and anti-bonding molecular orbitals. Yeah, for oxygen molecule, not only oxygen, any molecule, easy to find out its energy level diagram by knowing its atomic number. Easy to write its energy level diagram, a rough diagram. Just see here, and to write here. 16 electrons. 16 electrons means oxygen plus oxygen. Here the 8 plus 8 O2 molecule. 16 electrons are there. First write its electronic configuration 1s2, 2s2, 2p4. Here also 1s2, 2s2, 2p4 like electronic configuration. Without while doing the objective problems, without doing any energy level diagram, simple here. 1s and 1s get cancelled. Here 1s and 1s get cancelled. Here 2p4 are there. Last p energy level only. So keep in your mind above 14 electrons energy level diagram, sigma 2pz is the lower than compared to the pi 2px and pi 2py. That's why very simple is take like this. This is the simple energy level diagram 1 and here 1. So this is a simple diagram for O2 molecule. See it? Yeah, the 2s and 1s energy level diagram we know, but they are get cancelled because in both the oxygen atoms equal number of electrons are present. Number of bonding and anti-bonding electrons are same, similar, get cancelled. No need to write these two, just understanding purpose like. This is the sigma 2pz. This is the pi 2py, and this is the pi 2px. This is the pi star 2py, and this is the pi star 2px. And here one more maybe take, that is the vacant, empty this is. For this oxygen molecule, easy to find out. This is the sigma star 2pz. For this oxygen molecule, number of electrons present in bonding, lower energy level here 2, here 2, here 2, total 6. Number of electrons present in anti-bonding are 2 because here 2 and here 2. So its bond order BY is equals to 1 by 2 into 6 minus 2, that is 4 by 2, that is 2 bond order. Then here oxygen there exists even double bonds. So by using this, we can create the story based on the given question. See, it is a paramagnetic in nature because 2 unpaired electrons are there, and magnetic moment is to find out. Number of bonding and anti-bonding is to find out. On the basis of this, if they'll ask O2 minus 1 electron is added here. If they'll ask here the O2 minus 2, one more electron is added here. If they'll ask O2 plus 1 electron is removed from here. O2 plus 2, one more electron is removed from here. Then easy to find out its energy level diagram and number of bonding and anti-bonding electrons. If you know the number of electrons present in bonding and anti-bonding, then easy to find out magnetic behavior, magnetic moment, and its bond order, strength, and stabilities. Based on this, a variety of questions they'll create and already given. I think with you, there is material in our WhatsApp. Just today I'll complete these bond order concept problems. Remaining any other problems are there, any questions are there, better you solve it yourself. And we'll start Monday. On Monday, one more important new chapter. Okay. See here, question number 53 already completed while explaining characteristics of ionic and covalent characteristics explained clearly. And question number 52, which of the following diatomic molecular species has only pi bonds according to molecular orbital theory? Last year it was given, 2019. In 2019, one question given, in which of the molecular species that is only pi bonds only present, that is O2 molecule given first option. This is question NEET question 2019 in our material, question number 52. This is now the second option is your N2 molecule. Third option is C2 molecule. Fourth option is B2 molecule. This is. So in this, generally we know between oxygen and oxygen there exists one double bond. And here nitrogen there exists one triple bond. And in carbon and carbon there is a double bond is present. B2 there exists a one single bond is present, B and B. Sir, how to find out its bond order, sir? Number of bonds, sir, by using a shortcut. Your 16 electrons are there. If it is 16 electrons, its bond order is equals to 2. 2 bonds are there. Your 14 electrons are there. Its bond order is 3. Your carbon 12 are there. 12 electrons are there. Given increasing and decreasing above 14 electrons, below 14 electrons. Your 13 electrons are there, 2.5. 12 electrons are there. Its bond order is only 2. Your beryllium atomic number is here 4. Total 8 electrons are there. So this bond order is to find out your beryllium atomic number 4 plus here 4. Total B2 beryllium. Your 1s2, 2s2, your 1s2 and 2s2. Your these two are completely matched with this. These two are completely matched with this. There is no electrons. Number of bonding electrons must be equal to number of anti-bonding electrons. So its bond order is equals to 1 by 2 into Nb minus Na. Now your 1 by 2 into number of electrons are 4. 4 minus 4 both are same, equal to 0. Bond order is 0. Sorry, here there is no bond, just weak van der Waals force existed. So bond order is equals to 0. Anyhow, among these 4 examples, which one has only pi bonds? Here it contains sigma and pi, both are there. Here it contains sigma and 2 pi bonds. But in carbon, atomic number 6, number of electrons are 12. It contains only 5 electrons. Answer is this. How, sir? Only pi bonds. Here 2 bonds are there. One is sigma bond, another one is covalent bond. Sigma and pi covalent bonds 2 are present. Theoretically, according to the VBT theory, okay, sigma and pi covalent bond. But according to the energy level diagram, for oxygen, for carbon molecule, 1s2, 2s2, 2p2, here only 2 electrons only present. Here only 2 electrons only present in this. And for this energy level diagram is, for this energy level diagram below 14, that's why lower energy level is this and higher energy level is this. And here it contains here only 2 and here 2 electrons. These 2 electrons are first here 1 and here 1. Then one more is here and here. So here 1s and 1s get cancelled, 2s and 2s get cancelled. Only electrons are present in this pi 2px and pi 2py only. Here 2 and here 2 electrons are present. There is no sigma electrons. Here the sigma 2pz, no electrons. That's why in a carbon C2 molecule, among these 2 bonds, these 2 bonds are the only pi bonds are present. There is no sigma covalent bond. That's why to find out the number of sigma and pi bonds, number of bonding and anti-bonding, like a rough diagram must. So for this Question number 52, answer is third option. Carbon molecule contains only like. Question number 51, we know already. Number of sigma and pi bonds are present in pent-2-ene for ine. Question number 51. Yeah, the number of sigma and pi bonds. Sigma and pi bonds are present in pent-2-ene for ine it is. Pent means 5, 1, 2, 3, 4, 5. At second carbonate, there is a double bond like 1, 2, 3, 4, there is a triple bond like. Remaining all are the hydrogen atoms. This is the molecular structure of pent-2-ene for ine. This is sigma bonds 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 sigma bonds are there. Pi bonds are 1, 2, 3. 3 pi bonds are present. This is the answer. For this, if you know the IUPAC name and how to write its structure, then is to find out its number of sigma and pi bonds. So here, 49, question number 49, 2018 given in 18 NEET examination. 4 species given, question number 49. Just I am discussing about MOT theory, molecular orbital theory questions only. Here 4 species given, here the CN plus, here the CN minus, here NO and CN this is. Which one of this will have the highest bond order? Very simple this is. Now create the table like this. Within a given stipulated time, create one table, number of electrons. Carbon 6 plus 7. 13, remove one electron, here are 12 electrons. Yeah, the 6 plus 7, 13, add one electron, 14 electrons. Here the 7 plus 8, 7 plus 8, 15 electrons. Here carbon 6 plus 7, again it is 13 electrons. So we know if it is 14 electrons are present, its bond order is 3. Highest bond order this is 2.5. Here 13 are there, again here 2.5. Then here 12, it is 2 bond order. So highest one is this. Answer is CN minus. So if you know the simple shortcut table, given shortcut table, then is to find out its bond order. So highest bond order is CN minus, that is equal to the nitrogen molecule. Next. See the question number, which one of the following pairs of the species have the same bond order? Question number 44. So, question number 44, one pair given among this given pair, which one has the highest bond order? Question number 44. Your pairs are given like O2, NO plus, second pair is CN minus and CO, third one is N2 and O2 minus 1, fourth one is CO and NO given like this. Then immediately find out for all these. Number of electrons 16, here 7 plus 8, 15, remove 1, that is 14 electrons. So here 3 bond order, its bond order is 2. So which of the following pair has the highest bond order? One is 2, one is 3. See here, second one is carbon is 6, 7, 13, 1 add 14 electrons. Here 6 plus 8, 14 electrons. Both are having bond order is 3, bond order is 3. So answer is this is the correct answer. By using shortcut, by using very simple shortcut. So for that, second option is correct one. So the question number 36, increasing and decreasing order of stability of the molecule. Then 32, 33 same. 27, see the 27? Which one of the following is a paramagnetic in nature? Then question number 23, during the change of O2 to O2 minus 1 ion, the electron adds on which one of the following orbitals? We know the energy level diagram of oxygen molecule while changing the O2 to O2 minus 1. Addition of electrons takes place in which energy level? So automatically, so after filling this energy level, your O2 minus 1 electron is added, compulsory, that is entered into the pi star. That's why answer is for this pi star orbitals only, pi star molecular orbitals. So electrons entered into the respective pi star orbitals. Question number 23. 22, same the pair of species with the same bond order, just like explained like the same bond order. Then question number 20, bond order of 1.5 is shown by O2 plus 1, O2 minus 1, O2 minus 2, O2 given. So are the O2 plus 1, O2 minus 1, O2 minus 2, O2 given. See it? Your 15 electrons, your 17 electrons, your 18 electrons, your 16 electrons. Now your bond order is 2. Bond order is here 18 electrons are there, radius to 1.5. 17, 18 means 1 it is. Bond order is 1. Your 1.5. Your this is 2. Your 1.5. This is 1. Now this is also a 2.5 like this. So highest bond order given, that is sorry, 1.5 is O2 minus 1. This is correct answer. Okay, so like all models, almost all models covered here in this previous year NEET 6 to 19 years questions. And one more important simple concept is isostructural and isoelectronic species. So many questions are there. Better based on VBT, whisper theory and hybridization, better you solve all these questions. Remaining problems or assignment, better you read from given college material, will get a very good marks. From chemical bonding 3 questions and thermodynamics 2 questions, 5 marks, 5 questions. Maximum 20 marks in NEET will get it. Better do without any mistakes, negative marking, guarantee will get 20 marks out of 180. Monday we'll see and with a new concept. Take care. Thank you.